Welcome back, my friends, to the show that never ends. I'm Gene Del Sala, president of Audioholics, and today we have a very special guest. We have Mr. Shane Rich, technical director of RBH Sound. How you doing, Shane?
Doing great. Good to be here with you, Gene.
Awesome to have you here, Shane. Shane is the guy that's responsible for all the great sound at RBH. He's the guy that's behind the protractors and the measurement devices, and you have it, that basically makes these speakers sound the way they do.
Yes, it's a lot of fun, actually, to be able to be responsible for a product that sounds really great. Of course, the downside to that is if it doesn't sound good, it's all my fault.
And you'll be hearing from me if that's the case.
That's right.
So, I think we should do a series of videos here. I think we should focus on this video on just loudspeaker drivers, okay? Because a lot of people see the driver on the outside, they see the cone, they see the shiny metal, but they don't really know the magic behind it and what makes a good driver from a bad driver. Mm-hmm. So I think I have a series of questions maybe I can ask you, and you could just kind of give me some responses of what you think makes a good driver a bad driver.
Sure.
So, the first thing I'd like to ask you is why some manufacturers claim they make their own drivers. Mm-hmm. And we've actually found a lot of these manufacturers really don't make their own drivers. They just take an off-the-shelf driver, anodize it a different color, bam, it's their driver. Mm-hmm. But there are cases where, there are some customizations to drivers. And I guess the question I have for you is, when do you decide to use an off-the-shelf driver versus when you actually design a driver from the ground up, perhaps like your mid-range driver?
Right. Well, that's a great question. I know for us, just to give you some background on our metal cone drivers, that all started about 20 years ago. Started doing some design development on what we're really using now. It's just been a bit of an evolution from what we came up with 20 years ago. I've been always under the thought that, it's really important to start off with a great quality component to be able to ultimately get good sound from a speaker. You have to start off with a great quality component. And you're right, if you don't have something that really meets your design criteria to begin with, then and you can't find something off the shelf, not that there's anything wrong with that, but if it's not there, then you've got to go start doing it yourself. And so there can be cases where that's necessary. And for us, with our metal cone drivers, there really wasn't anything on the market 20 years ago that had that particular design criteria that we were looking for in a metal cone driver, and so we started our own. Now there are other drivers that we have been using for years and years from other reputable manufacturers such as Vifa or ScanSpeak, and the thought process there was this is already a fantastic product. No reason to reinvent the wheel when there's something so good that's already very usable.
Understood. One thing I liked about your metal driver, like the 6.5, and you're right, these drivers have been around forever. Mm-hmm. Let's go back 10 or 15 years ago when this driver was relatively new. A lot of the aluminum drivers on the market, they suffered some pretty bad resonances and ringing. They had a breakup mode that was within the passband of the driver. Yeah. And I know you guys have taken measures. I don't want to speak for you, but I know that you've done some unique things, whether it was coating the actual cone or actually just the rubber surround itself to dampen these resonances. Can you, maybe elaborate on that?
Yes. Well, again, going back to when we were originally looking at doing some metal cone products, I looked at what was currently available and found the performance to be very substandard. Some of them were even touted as really high performance drivers. They looked really nice, were built of, good materials, a nice cast basket, and the cone itself seemed to be fine, but there were still resonances, as you said, in the passband that were causing issues. So it then became a bit of a challenge to see, well, what can we do to improve on something like this? And we've taken it, of course, to where we are now, where yes, that breakup mode, primary breakup mode that occurs in any rigid, stiff material that's used for a cone or dome is by its very nature going to be a problem unless it's moved out of the passband. So, and for those of you that aren't quite understanding that terminology, you essentially want to move that breakup mode beyond the crossover point for that driver. So we do some things that are proprietary. The president of the company, RBH, Mr. Roger Hassing himself, has told us before, if you tell anyone, we'll have to kill them.
There you go. I still don't know. That's why I'm still here.
But there are some things, and I'll just put it in general terms, with the surround and with coatings on the driver that do help to shift that breakup mode, primary breakup mode, outside of the passband of the driver.
Yeah, and another thing, here's another thing that you don't see, and we'll do another video on this, is behind the cabinet you have the brains of the speaker called the crossover. And if you don't get the shape of the crossover right, the response, again, even if you get that breakup mode beyond the passband of the driver, if you don't properly filter, you're still going to have some of it down, 30, 40 dB, and that's why you need a good crossover to really just nuke it, right?
Yeah, absolutely. There are some people that will use notch filters. We initially started off using a notch filter and got to the point with driver design that it wasn't necessary to use that notch filter because it interjects some other issues into the whole crossover equation. But yeah, it's very important to roll the driver off so that you don't have any of those breakup modes that are occurring in the breakup band or the stop band of the driver that are really going to be audible, especially at louder volume levels. We think of crossover points. Well, you have a driver that might span a frequency range of 100 hertz to maybe 2,000 or 2,500 hertz. It doesn't just drop off.
Right, it's not a brick wall.
Exactly, it's not a brick wall filter. It gradually rolls off, and it's really important to design a crossover that takes the natural roll-off characteristics of that driver and enhances that roll-off in a manner that is still going to allow for good integration with the driver beyond the tweeter, in this case with a mid-range. Still going to have good integration, designing those filters so that you get the correct acoustic summation.
And you guys, you'd be surprised. I mean, obviously good crossover parts cost money. You'd be surprised at how many speakers are on the market that use these stiff metal cone drivers, and you open up and there's no crossover on the mid-range. I mean, it's just running full range. You could physically hear the breakup modes, when not even just with test tones, but just with program material. And then when you go and do a near-field response, I mean, it's just, you can see it's raggedy right where the tweeter and the mid-range integrate. And the thing that always kills me about your speakers is, everybody says you got to use an anechoic chamber to measure a speaker. I can literally take a 6.5-inch two-way from RBH, measure it at a meter in the room, and it looks anechoic because the integration between the woofer and tweeter is that good. Yeah. And I often use these speakers as a reference to make sure my measurement gear is working right.
Well, that's good to know. We appreciate that plug there. But it's true not only for the mid-range driver, also for the tweeter as well. If you have a tweeter that's trying to play down too low, that's actually, I think, the most common problem with a speaker design, a two-way or even three-way,
yes,
is that people are trying to run tweeters too low, and just to the point that you're getting a lot of distortion, especially at high levels.
Yeah, because a tweeter, like you take a tweeter like this. This is from the $50,000 the Status Acoustic speakers. Mm-hmm. This has what's called like a low resonance, right? It's like a 500 or 600 hertz resonant frequency.
Yeah.
And if I'm correct in assuming this, when you cross over a tweeter, you want to cross it over at least 2 octaves above its resonance, right?
That is a general rule that if you can, follow that, you're usually in a good place with your tweeter. It isn't a hard and fast rule. There are situations where, depending on how much output you want from that particular system, you may have to extend that beyond the 2, or you might be able to go down a little bit further from that, less than 2 octaves, with a bookshelf where you don't have to worry about playing it as loud as you would a $50,000 speaker that has 4 mid-range drivers in it.
Yeah, well, I mean, we've seen speakers that had, they don't have a rear chamber like this. This is partially responsible for its low resonance, right? It's the rear chamber.
Yeah.
You'll get some of the budget tweeters that don't have the rear chamber, and their resonance might be at a kilohertz, and the manufacturer is crossing them over at 1500 hertz. Yeah. And that's when you get in trouble, when you're getting that close to resonance.
And really, usually it's an octave. You want to be at least an octave above to avoid any issues. And it just depends on the driver design itself and what type of distortion and how much distortion is being produced at those lower frequencies, and it can vary drastically from driver to driver.
Right. Well, if you look at the RBH products, you notice that they make their own mid-ranges, they make their own bass drivers, most of them, right?
Yes.
Most of your subwoofer drivers. But most of your tweeters are OEM. Like, for example, this is what's the model number on this? The Illuminator?
Yes, that's the ScanSpeak Beryllium. It's the Illuminator. Can't remember the model number.
It's a huge number from what I
but,
remember, but this is a crazy tweeter. This is like a $500 tweeter. It's insanely priced, but it's a great performer. But even in your entry-level bookshelf, you still use like a VIFA Silk Dome. You've got the ScanSpeak 9500 in the higher end version, and now you have this new AMT. I guess the question I'm asking you is, why are most of your tweeters off-the-shelf drivers and not your secret sauce?
Well, it's interesting because in our some of our lower-priced product, we do have our own tweeters that we've designed, and I've used the V4 ScanSpeak tweeters as sort of a target for design purposes to try and get the same kind of performance that these types of products have. The bottom line is, why reinvent the wheel when you've got a wheel that is functioning so well? These are just such good products off the shelf. There's really no need to reinvent unless we're trying to hit a lower price point,
right? And
then we're trying to design something that will have similar performance, but be a little less expensive.
Well, yeah, you look at a company like VIFA. These guys, that's all they do all day long is make drivers, and this is a reputable manufacturer, so they've got good QC, and you get off-the-shelf consistency, right? When you measure.
Oh yeah, very consistent. We've been very happy with. As particularly those companies that have been vendors for our tweeter products over the years. That's one thing you get is very good consistency when that's all they do are drivers.
Well, I could tell you guys, I've been listening to RBH speakers for probably almost 15 to 20 years. I've never blown a tweeter.
Yeah.
And I could blow the snot out of these things. I put them loud for demos, and that speaks volumes, because I've blown tweeters out on other speakers before, but I've never had that problem here.
You need, again, a good quality component to begin with, and then good crossover for integration.
Right. So, before we get into the AMT, I wanted to talk one more thing about tweeters. You see this tweeter here, it's got a flat faceplate. There's a lot of companies that use a waveguide in their tweeters, and that's to control directivity, but it also allows the tweeter to be more efficient at lower frequencies. Now, in my opinion, a lot of the tweeters with the waveguides are kind of done on the budget designs to give you that higher, sensitivity at the lower frequencies. But why is it that a lot of these high-end tweeters, like this one, for example, why is there no waveguide on it? And why are most of your products don't have a waveguide?
Usually when you get to this type of product, in terms of quality, you just have the motor structure and overall design of the mechanical design of the tweeter itself, especially at higher excursions where it's just designed with low distortion in mind. And so, what you might do otherwise to bypass a lower resonance frequency, or to not have to go to the extreme with a chamber to give you a lower resonance frequency in some products, is to build that waveguide in that will give you more sensitivity at lower frequencies. So, it's a design choice. I'm not saying it's it's any less viable than what you have maybe with a tweeter that's designed with a lower resonance frequency. But in our designs, we choose to go with the lower resonance frequency tweeter versus using a waveguide. And in most cases, we have had products with waveguides as well, but they're usually a lower price tweeter.
Yeah, like your MC line, for example.
Yeah.
Okay. So let's talk about this AMT. We've, in the last couple of years, we've seen everybody coming out with speakers with AMT. And I remember in our discussions, you weren't quite happy with most AMT tweeters.
Yeah.
Tell me why, and tell me why yours is different.
Okay, sure. Well, and as you know, Gene, you'd been asking me for several years, why aren't you doing an AMT tweeter? And the fact is I'd been working towards doing one for several years, like you said, and I just hadn't been happy with what we were able to come up with, or with vendors that were offering those types of products that were readily available. I'd gone through several different modifications that I had performed on off-the-shelf products that were supposed to be really high-end and were being used in other speakers. I was not sold on their performance. Too many issues, mainly with resonance of the AMT driver ribbon diaphragm.
What is an AMT? Let's just tell people what it is.
Well, an air motion transformer, and there are different names for it. Heil was the first iteration of that type of product decades ago and had a patent on it, and it's only been the last maybe 10 years or so that more of those products have started to come out and use that particular type of technology. What it is it's essentially functions like an accordion where you're squeezing the air between pleats versus moving a diaphragm back and forth to move the air. So there are some advantages to it. One is that it has a lot of surface area. This is the diaphragm from the tweeter that we're currently using in our SV, top-of-the-line SV products we're going to be coming out with. And the real difference between this and what has been on the market is that this uses a material that is much less susceptible to having those resonance issues that I had previously talked about. It just makes a world of difference. The last thing you want, again, is a tweeter that's breaking up when it's driven too hard at low frequencies.
Yeah, and you can hear that. So this is a metal diaphragm, kind of like your metal cone woofer.
Yeah, this is an aluminum diaphragm, actually, and has some natural characteristics of self-damping, some self-damping properties that eliminate the types of resonance problems that you can find with Kapton or Mylar or other similar types of material.
Gotcha. Well, thanks for the education here on these different drivers. Is there anything else you wanted to talk about, driver design, that, something that you look at that maybe other people's that design speakers or even consumers may not notice in a driver when they're looking at one speaker or another?
Well, one thing that's been more sort of one of my pet peeves is when manufacturers will come up with a design that's one of their higher end loudspeaker designs, and then they stick to just one mid-range driver. As you know, we prefer using more than one mid-range driver just so that the speaker, especially a larger speaker, has dynamic range throughout the full band of frequencies, not just the woofers, but through the full band, through the mid-range, and
I think we're going to do a video on driver topologies, because that's an area I would like to discuss with you as well. I think what happens is a lot of manufacturers get stuck on just how good something can measure on and off axis, but they sometimes don't account for dynamic compression, because most of the manufacturer curves are done, let's face it, they're done at 1 watt or 1 meter, 2.83 volts, maybe 90 dB or 88 dB. You can't tell how a speaker misbehaves until you really drive it.
That's correct.
And when you got the multiple drivers, you're cutting down on distortion, you're increasing your output capability as well.
Exactly.
But I think we should save that for another video.
Sounds good.
Okay.
Look forward to watching that.
We're just saying it like it is right now, so we don't even know how it's going to go. But anyways, guys, I think that's it. I think if you have any questions on loudspeaker drivers, this is the channel, this is the video to ask them at. I'm sure we can get Shane to kind of look through and, after the video posts and maybe put some feedback. I'm committing you to putting some feedback into this channel. And I think this is a topic, drivers are pistons. They're mechanical devices, but they're kind of nebulous because you don't see the whole picture. You just see the front face of it. So I think it's good to give some education on this and get people to appreciate what goes inside of a speaker and not just the outside of the looks and the sound.
I agree. I think it's great what you're doing.
Appreciate that, Shane, and thanks for being here. And guys, until next time, keep listening.